अटेंड करनी है. Good morning, students. Welcome to your science period. So today we are going to start with a new lesson, that is lesson number 3, force and pressure. What is a force? What do you understand when I say force? Any idea? Yes? Force is a push or pull upon an object resulting from the object's interaction with another object. That is, two objects, they interact with each other and the result is called as the force. Now you can see these pictures. What do you understand by looking at these pictures? Come on, I am giving you time to look at the pictures and then I will explain you. See, the first one is car is moving in the forward direction and the man is applying force from behind, right? So there is an interaction between the man and the car. He is pushing the car. Second one is, you can say, a reluctant dog is pulled by his master. Okay, so here also there is an interaction between the dog, that is through the leash, and between the boy. So the boy is pulling the dog towards him. Here also he is applying a force in the form of pull. And third one, yes, he is kicking the football, right? So he is applying force on the football, because of which the ball is thrown away. So students, here you can two slides, two different pictures, right? In the first one, the man is pushing the car. Second one, the boy is pulling the dog. And in the third one, the boy is kicking the football. And in the second slide, you can see the magnet. The nails are there. In the second one, you can see the comb and pieces of paper which are attracted to the comb. And third one, you can see the coconut from the tree falling on the ground, right? Now, can you tell me what is the difference between these two pictures? Yes, come on, think, students. Now, in the first picture, there is a direct contact between the two objects, right? Interaction is taking place between two objects directly through contact. The man is pushing the car through the hands. The boy is pulling the dog through the leash. He is in direct contact with the dog. And the boy has kicked the football. So he has a contact with the ball. Whereas in the second one, if you observe, the magnet attracts the nails without contact, right? So some interaction is taking place between the magnet and the nails, because of which the nails are attaching to the magnet, right? Now in the second one also, the interaction is there, but the contact is not there. When the comb is brought near these pieces of paper, the pieces of paper, they get attached to the comb, right? So interaction is there, but without any contact. In the third one, you can see the coconut is falling from the tree towards the ground. There is no direct contact, but the interaction is taking place. The coconut is falling from the tree to the ground. Okay. So now we are going to study about contact force and non-contact force, right? Contact force, as I said, a force is seen to act through a direct contact of the objects or via one more object, right? So this is the contact force. There is a direct contact between the two objects and then the interaction takes place. This is called as the contact force. We will be studying the examples in the further lecture. Second one is non-contact force. A force applied between two objects are not in contact. See, when we place the nails in front of the magnet, we are not touching the nails with the magnet, but on its own the nails are attracted towards the magnet. Students, if you remember in 7th standard, as I was teaching you science, I had shown you the explained you the laws of magnetism. If you remember, the like poles attract each other and unlike poles, sorry, I said it wrong, like poles they repel each other and unlike poles they attract each other. And if you remember, I had shown you the bar magnet, two bar magnets with same poles towards each other. They could not be brought near each other because their like poles were in front of each other, so they repelled each other. Whereas in other case, I had shown you the magnets, two bar magnets with opposite poles, one's north pole and the other south pole were in front of each other, and they immediately contacted, they immediately got attached with each other, right? So even if the gap is there, the contact is not there between the two objects, the interaction can be seen, the force is seen. So this is the example of magnetic force. Second one, this you might be doing in the class also so many times. You have to just rub your plastic comb with your hair, and when you bring pieces of paper near it, they get attached to the comb. This is the electrostatic force. And the third one, you all know very well, right? That is the gravitational force. So because of the gravitational force, the coconut is falling down. So these are the examples of the non-contact force. Okay. So here are the examples of the contact force and the non-contact force. As I explained you, contact force takes place when the two objects are in touch, when they touch each other, when they are in contact. Like the muscular force, we use our hands or legs to lift something, to push something, or to pull something, to kick something, right? They are in contact, they are touching each other, and thus it is called as contact force. Second one is non-contact force, where the two objects, they do not touch each other, but still the force can be observed. And the examples are magnetic force, gravitational force, and the electrostatic force. In all these three, the objects are not touching each other. They are not in contact with each other. They are far away, but still the effect of force can be observed. Next we are going to study is the frictional force. Now what is frictional force? The force which is generated by two surfaces which are in contact and which slide or rub against each other. So such a force, when it is generated, is called as the frictional force. And this force is mainly affected by the surface texture and quantity of force requiring them together. Now, very simple example. When you walk on the ground, you have to push the feet behind, and then only you can walk further. Now, if the ground is very smooth, right, then what happens? You are not able to walk further because you slip, because there is no grip for your feet, right? And you are not able to walk. Like if you stamp on a banana peel, you fall down. Why you fall down? Because the banana peel is very smooth, and when you try to push your feet behind, you fall down. Nothing can stop your feet. There is no friction, right? Okay, now a very simple example I give you. When you go to the malls or to big markets, there is a slant to walk. There is a slope, and there are steps also, right? Staircase also. Now if you are walking on the slope, it has to be uneven. It should have uneven surface so that you can hold your feet, you can have a grip and you can walk, right? Basically the rough surface resists and thus you are able to walk. You might have seen that those ramps, the tiles are not smooth. They are arranged in such a way that the surface becomes uneven so that you can walk smoothly with a grip on the slope. Okay. Now we are going to study about balanced and unbalanced force. And now I am going to show you a video with the help of which you will understand the balanced and unbalanced force very easily. We have to arrange the things as shown in the picture. We have to take a cardboard box. We have to arrange it on the table in such a way that the two pans are tied on the two ends of the string, and on that string the cardboard box is placed. Now we can see that the pans are at the same position. Now we have to take two equal mass and we have to place in both the pans. Now we see that when the pans were equal, the mass was equal in both the pans were at the same balanced position and the box also did not move. But as we increase the amount of mass in one of the pan, the box moves towards the pan in which the mass is more. Why? Because now the mass is more, so the more amount of gravitational force is acting on this pan and the box got shift toward this pan. That means the two forces which are acting on these pans are unbalanced, right? So this concludes that when unequal forces are applied to the box on the two sides, an unbalanced force acts on the box, resulting in imparting motion to the box. The next example is tug of war. When you play tug of war, if the force is equal on both the sides, then none of the teams win. But if any one of the team applies more force, then the rope is pushed towards them because the force is unbalanced and thus they win. So this shows the balanced and unbalanced force. So students, what do we understand from these examples? I had shown you so many examples. We understand the following things. First is that if several forces are applied on an object in the same direction, a force equal to their addition acts on that object. Now suppose we are applying three forces, right? So a total of all these three forces will act on that object if they are in the same direction. This is the first point. Second is, if two forces are applied on one object in opposite directions to each other, a force equal to their difference acts on the object. Now suppose two forces are applied on one object but in opposite directions, right? So what will be the force applied? That will be the difference of these two forces, right? Now third is, a force is expressed in magnitude and direction. You remember in 7th standard we had studied the vector quantities and scalar quantities, right? Vector quantity has magnitude as well as the direction. So as we saw in the second one, that if the forces are acting in the opposite direction, the force is equal to the difference of them. And in the first one we had seen that if the two forces are applied in the same direction, then the force is equal to their addition. So the direction does matter in case of force, right? Not only the amount of force, but direction also is very important. Thus, force is a vector quantity. It is expressed in magnitude as well as direction. Okay. So students, just observe this picture and see what this man is doing. Yes, what do you see? The man is filling air in the tire. Now how he is filling the air in the tire? What he is doing? He is applying force on the pump, right? And the tire becomes full. Now he is applying pressure. Now the pressure which he is applying depends upon the force which he is applying and the area on which the force is applied. Okay, this is called as the pressure. So the force exerted perpendicularly on a unit area is called pressure. And the formula for pressure is force upon area on which the force is applied. That means, as I said, the force is a vector quantity. It has the magnitude and the direction. Now it depends upon the area on which the force is applied. Okay, this is called as the pressure. So when the air is filled in the tire, how we come to know how much pressure is applied in the tire? You might have observed that the digital meter is there in the shop which shows the amount of pressure which is applied in the tire, right? So how do we read the pressure? We read the pressure by the unit of Newton, right? Now when we find out the pressure by the formula force upon area on which the force is applied, the force is Newton. The unit of force is Newton. It was given by the scientist Newton, and the area is measured in meter square. So the unit of pressure is Newton per meter square, and it is written as Pascal or PA, right? Like we write kilogram in kg, gram in g, liter in L, milliliter in ml. Similarly, the unit of pressure is Newton per meter square or Pascal. Okay. Now in atmospheric science, the unit of pressure is bar, and 1 bar is equal to 10 raised to 5 Pascal. Okay. So 1 bar means 10 raised to 5 Pascal. See, we had seen just now that pressure depends upon the force and area, right? Now just observe this picture and try to understand what I want to show you. Now what we have done, we had taken a wooden plank and we had placed it on 2 blocks. And in the second one, we had placed 4 books, but the books are spread on the plank and the position of the plank is not changed. In the third one, all the 4 books are kept one above another, and we can see that the plank has bent. Why? Yes, try to remember the formula of pressure. Yes, the answer is, now in the second picture, the books are spread. That is, the area is more. The force of those 4 books are same, but the area is more. The full plank is occupied by the force. But in the third one, the area is reduced to 1 book and all the books are placed on that books. So the area is reduced, the force is same, and thus the pressure becomes more. So the area reduces, the pressure increases. This is what is the pressure on the solids. Okay. So it is, the pressure on solids depends upon the value of weight and the contact area between the two. Yes, just observe this picture where you can see 2 cylinders. The first one it is written low pressure, and in the second one it is written as high pressure. Now what do you understand looking at these pictures? And you can see the digital meter also. Now in the first cylinder, the molecules can be seen, they are very spread out, right? And thus the pressure is low because the area is more. But in the second one, the pressure has increased because, yes, the area is reduced, right? So in a gas also, the particles, they apply force on all the walls of the container, and when the area is reduced, the pressure is increased. So the area reduces, the pressure increases. The area increases, the pressure reduces. Third, we will study about the pressure of liquid. Now the third we are going to study is pressure of liquid. Now in case of liquid also, it exerts pressure on the wall of the container. For this we can perform these two experiments. In the first one, we have to make a hole in the lower part of the bottle, and with the help of a pipe we have to put a balloon on it, and we will see that the water from the bottle enters inside the balloon. Why? Because the liquid exerts pressure on the walls of the container, and this comes out in the balloon and the balloon gets filled. In the third one, you can see a bottle is filled with water and 3 holes are made at 3 different points. Now when the water falls from these 3 points, we can see that the uppermost hole, that is 3, the water falls near to the bottle. In the second one, it goes little further, whereas from the last one, that is first hole, the water falls the farthest from the bottle. So what do you understand by this? That the liquid pressure is same at any level, but as the depth increases, the pressure of the liquid also increases, and that is the reason why from third hole the water falls very near to the bottle. From the second, the depth is little more than the third one, so it goes little far, and the first hole is at the deepest of all these 3, and thus the water pressure is the maximum. So this is the pressure of liquids. Now the next we are going to study is atmospheric pressure. Now what is atmospheric pressure? So you know that air surrounds the earth from all the sides, right? This layer of air is called atmosphere. Now this atmosphere, it exists about till 16 kilometer in height, and further it extends up to 400 kilometer in a very dilute form. As we go higher, the air becomes less, right? Now this pressure created due to air is called as the atmospheric pressure, and at sea level it is 1 atmospheric pressure. Now 1 atmosphere is equal to 101 into 10 raised to power 3 Pascal, which is equal to 1 bar, and which is equal to 10 raised to 3 hectopascal. 1 m bar is approximately 10 raised to power 2 Pascal, that is hectopascal. Now how is this pressure created? Now we had seen that if air exists in a closed container, the air molecules in random motion continuously hit the walls of the container. In this interaction, a force is exerted on the walls of the container, and the pressure is created due to this force. So this is all about atmospheric pressure. Now this is how you can understand the atmospheric pressure with the help of this experiment. Now you can see that the container, the molecules are present, and these molecules are exerting pressure in all the directions. Okay, and thus the force is exerted on the walls of the container. Similarly, on our body also this atmospheric pressure is exerted. However, the cavities in our body are also filled with the air, and the arteries and veins are filled with the blood. So therefore we don't get crushed due to this atmospheric pressure. So students, a very small content of the lesson is remaining, and we will continue the remaining part of the lesson in the next period. And I hope you are completing your workbooks on time. And yes, one very important thing, you might have enjoyed your live feedback session of science today. Similarly, I hope your same cooperation in the coming live sessions. Thank you.